Hello. Hi students, welcome to Vedantu J English. I'm Diksha, your chemistry master teacher, and today we are going to discuss some very interesting questions for your JEE Advanced. Previous year questions we have taken out, right? And just like we discussed for chemical bonding and coordination chemistry, what you must have observed that in chemical bonding coordination chemistry, still predictable kind of questions were there, but in physical chemistry, a lot of twists also you will see in the questions. Okay, so let us start this without wasting any time. So all of you, are you ready for that? Yes, everyone. Very good afternoon. Very good afternoon. So these three chapters are very important, like very important, especially electrochemistry is like a good level of questions they ask from electrochemistry, right? Then kinetics, easy questions they ask from chemical kinetics. Solution also not very tough questions they ask for solutions, right? Here I would say this is easy category, this is easy category. From electrochemistry, they can go from easy to moderate to difficult as well, right? Okay, so you have to be prepared for everything. Till here, they can go from easy to moderate, but in here also easy to moderate, right? Let us start the questions without wasting any time. Everybody pick out your, yes, pick out your pen and notebook and start doing the questions with me, okay? So first question on your screen is, oh my God, what is this paragraph now? Okay, you may see that is the thing with JEE Advanced, right? You may see that, okay, my God, this is such a difficult question, but actually it's an easy question. If I talk about JEE Advanced, this is not a very difficult question, okay? So the boiling point of water. So first you have to read the question, okay, and make something out of it, like what is the given things, what they are asking you. So they are saying that the boiling point of water in a 0.1 molar silver nitrate, you have silver nitrate, right? Where the boiling point of water in this much mole of silver nitrate solution is X degrees Celsius. Okay, boiling point of water is given to you, right? In this case, to this solution A, you have added equal volume of 0.1 molar equal barium chloride. Barium chloride you have added here, right? To make a new solution B, you had a new solution, that is B here, right? Is added to make a new solution. The difference in the boiling point, right? So initial boiling point you have to calculate. Initial boiling point you have to calculate for AgNO3, right? TB1. Then TB2 you have to calculate for AgNO3 plus BaCl2. First, you try to understand what the language is saying, right? And they are asking you, then you have to take the difference of them. Assume density of solution and B are same as of water, and the soluble salt dissociate completely. Use molar elevation constant, that is Kb. You can use this thing. Boiling point of pure water is 100 degrees Celsius. Now, students, very simply, firstly to calculate TB1. TB1 is very easy to calculate, you know. TB1, firstly, what is delta TB? Delta TB is bond Hall factor, because these are electrolytes, okay? Bond Hall factor multiplied by molality multiplied by Kb. Now, bond Hall for AgNO3. For AgNO3, you are calculating TB1, okay? So, here you have AgNO3, that means AgNO3 is dissociated into two parts, that is Ag positive and NO3 negative, right? So that means your bond Hall factor is 2 here. Molality is already given to you, that is 0.1, right? That is 0.1. Kb is also given to you, that is 0.5, right? So when you put it here, 0.5 is nothing but it is 1 by 2, right? So it will cancel and you will have 0.1 as delta TB. So whenever you are calculating the temperature, the boiling point, they are asking you the value of TB1. That means they are not asking you pure water, right? So that means you have to add 100 degrees Celsius here and this is 0.1. So it will become 0.1, right? Is it? Yes, 100.10 degrees Celsius. 0.1 also you can write degrees Celsius. That is your TB1. Now you have to calculate TB2. Okay. Now you have to calculate TB2. TB1 you have calculated, X you have already calculated, this is your X. Okay, that you have already calculated. Is that clear? Now for TB2, right? For TB2, what we are going to do, everybody? For TB2, what we are going to do? Very simple. For TB2, you have these two solutions. You are firstly going to see I is going to remain same here, right? You have to calculate the total molality and van der Waals factor multiplied by each other. So that will be if you see this solution now, TB2 is important for you. We know that BaCO2 you have and AgNO3 you have. If you see this solution, initially what they have given you is to this solution, new solution, the difference in this, wait a minute, they must have given you somewhere the boiling point. The boiling point of water is 0.1 molar. So if 0.1 molar is given to us, then can I take 0.1 moles here, right? So for that, you can take 0.1 moles also, because if molarity is given, you can take it as moles also. But condition is here you are taking solvent as 1000, right? Okay, when you're taking solvent as 1000 grams, solvent you are taking as 1000 grams. Okay, because what is molality? Molality is number of moles. Molality is number of moles divided by weight, right? That is in kilogram. That should be 1. If the weight of solvent is 1 kilogram, then molality will be equals to number of moles of solute. So we have taken the weight as 1000 grams, that is 1 kilogram. Then the molality is equals to number of moles. So you can easily write here that number of moles is 0.1. This is also 0.1 initially, right? Because both of them are given to be 0.1, equal volume of 0.1 molar they are saying, right? Both of them are 0.1. But if you see, if from here we are saying, let's assume that they are saying that all of AgNO3 is consumed. That means 0.1, that means this 0.1 is totally consumed here, that is 0.1. If here 0.1 is consumed, here 0.1 by 2 will be consumed, because here if 2 moles you are using, here you are using 1 mole. If here 0.1 is consumed, here 0.1 by 2 will be consumed, that is 0.05 will be consumed here. That is why you have to subtract this from here, that is 0.05 moles. This is 0 and this we have formed is 0.05 moles. Right? Now we will calculate the molality of new solution, that is I into M1. Here it is M1 because in the end what you will have in the solution, because all of AgNO3 is totally consumed. This is solid, we can't contribute it while calculating the molality, right? This we will take, this we will take, right? So this is 0.05, this is also 0.05. So you have 3, why? Because it has 3 number of dissociating, after dissociation it will give you 2 Cl and 1 Ba2 positive. It will give you 3, that is 1 Ba2 positive and 2 NO3 negative, right? So both of them have van der Waals factor 3. So it is 3 multiplied by 0.05, 3 multiplied by 0.05 divided by 2. That is the average we are taking here. So molality is coming out to be 0.15. Now next is very simple. You just have to put this formula here. That is delta TB. I'll take it as 2 because we are calculating for 2 parts. So this is the van der Waals factor into molality you have already calculated, multiplied by Kb. Libescopic constant, that is 1 by 2. Put the value here, you will get the value of TB2 here. Now, what is the difference? One is 100.075, other is 100.10, right? So you have to subtract it. The difference will be 0.025, that we can also write because they are asking you this in the integer form. That is written over here, that is, wait a minute, that is written, the value of y, where is y, yes, this one. They are saying the difference is y into 10 raised power minus 2. So you have to convert it into 10 raised power minus 2. So if you put y is equals to 2.5 into 10 raised power minus 2, that will be 0.025 only. So answer will be 2.5 is the correct answer Okay, understood everybody? So that was the first question from solutions. Next question is based on, so that was a mixture. Okay, that was a very interesting question. Okay, next question is liquid A and B form ideal solution. You have one liquid A, one liquid B. They form ideal solution. That means they follows Raoult's law, right? Okay. For all composition of A and B at 25 degrees Celsius, two such solutions, right, with 0.25 and 0.5 mole fractions of A have the total vapor pressure. See, if you are saying mole fraction of A is 0.25, the total vapor pressure there is 0.3. If this is 0.5, this is 0.3. If mole fraction of A is, let's say, 0.5, then total pressure is 0.4. See, if you have two components only, that means we know that mole fraction of A plus mole fraction of B is equals to 1. So you can calculate the mole fraction of B as 0.75, 1 minus 0.25. Mole fraction of B here will be 0.5. Now, can you put it in this equation where we know that according to Raoult's law, P naught A mole fraction of A plus P naught B mole fraction of B. Now you know the value of mole fraction of A and B here. A and B you already know, right? Okay. P naught A and P naught B you have to calculate PT also, you know. So that means you can equate two equations here by putting firstly this value here, then this value here, right? So you can get two values here. One is when you have point this and the mole fraction is 0.25 and 0.75. Other is when you have 0.4 is the total pressure, 0.5 is the mole fraction here, right? So with these two equations, like you have x plus y, x minus y, these kind of two equations, you can easily solve this by the mathematics, right? You have to just solve these two equations here, where two equations you have, two are missing. So what you can do substitution method. You can calculate the value of P naught from here, put it here, you can calculate the value of P naught B, then put it here, you can calculate the value of P naught A also, right? So directly by using substitution method, you can solve it, right? Now, next question on your screen is regarding, next question students. Now, these kind of questions which I find very interesting, which I feel are JEE Advanced good level of questions, not difficult, doable questions, but yes, okay, it's not like very direct questions, okay. So now here it is, 5 ml of 0.1 molar oxalic acid. Now, what is oxalic acid? COOH, that is your oxalic acid. Solution taken in conical flask is titrated against NaOH from a burette using phenolphthalein. Okay. So that means they are saying that this ml of oxalic acid is taken in a conical flask. So you have a conical flask here, right? Okay. So let me just make a good conical flask here, right? So you have a conical flask here and this is the burette that you have here, right? In the burette, titrated from the burette using this. Okay. So taken in a conical flask is titrated NaOH from a burette. Okay. So NaOH is in the burette, right? Okay. Here you have oxalic acid and you are using phenolphthalein as an indicator, right? The volume of NaOH required for the appearance of permanent faint color. Now they have given you some data. You are in the lab. So what exactly happened? In experiment 1, the volume of NaOH where there was faintness, that means where we said that okay, this is the equivalence point, that is coming out to be 12.5. In the second experiment it is 10.5, third it is 9, fourth it is 9, fifth it is 9. So we usually take up in experimental labs also, we take up that value. Now the question is, ma'am, which experiment should we use, right? I'll tell you the experiment that is again and again giving us the same value, that is your most probable value, that is 9 is your most probable value of volume of NaOH. So you will take volume of NaOH as 9 milliliter. Okay, that was the only thing here. Other things are very simple, right? So what you have here is the volume of this and this. What is the concentration in molarity of the solution? So what you have to do? You have to equate the number of equivalents here, right? Okay. So N1 V1 is equals to N2 V2 is what you have to do, right? N1 V1 equals to N2 V2, right? You don't have to divide it by 1000 because see, if you take this also in milliliter, this also in milliliter, that doesn't matter, right? Because 1000 will cancel each other. What is N1? This is N factor of 1, molarity of 1 V1, N factor of 2, molarity of 2 V2. Now molarity is given to you for both of them, right? Molarity is, this is 5 ml oxalic acid, 0.1 molar. So this is given to be 0.1 molar, 0.1 molar, right? So I'll write it as 0.1. Volume is given to be 5. So I'll take it as 5 milliliter, right? N factor of oxalic acid. See, oxalic acid is going to give you 2 hydrogens. So N factor is going to be 2 here, right? And what about NaOH? N factor is going to be 1 because it is only going to give you 1 OH, right? So I'll put the value here. This is V1. So this is going to be, volume is going to be V1. This is N2. N2 you will put it as, wait a minute. This is number of moles is given to be, wait a minute. How many moles are given to you? The volume of this required in a conical flask and from the bread is taken in a conical flask is, acha, concentration of this is only they are asking. I'm so sorry. So N factor is 1 here. M2 is what they are asking. Volume we take 9 and here it is given to be N factor is 1, right? Okay. So here I'll put it like this. Okay. N factor was 2, right? From there, solving this, you can easily solve the value of M2 here, right? So everything you have, just the value of M2 you have to calculate. You can easily calculate, that will come out to be 0.11 molar. So important thing was which volume you should take here, right? Usually students, what they do, they take the average of this. You have to see the most repeated value if any of them is the most repeated. Otherwise, you can calculate the average, okay? If nothing is repeated, then you can take the average. If one value is getting repeated again and again, you have to take the repeated value here, right? Okay. Next question is from electrochemistry. So here the question is, for the following cell, yes students, try to answer this. Ma'am, does evening stream of VA3 will contain organic part? Yes, definitely, that is majorly it will be organic, right? So for the following cell, Zn to Zn-SO4, CuSO4 to Cu, when the concentration of Zn2 positive is 10 times the concentration of Cu2 positive, the expression for delta G is going to be what, right? So now what they are asking you, that this is for the following reaction, we know that this is the anode side, this is the cathode side. Okay, so when the concentration of Zn2 positive, right, is 10 times the concentration of Cu2 positive. So can I say that Zn2 positive divided by Cu2 positive is given to be 10, right? The expression for delta G they are asking you, right? Okay, at equilibrium is it? Fibrate is this, this is this, this is this. Okay. We know that delta G is equals to minus NFE cell. Okay. Delta G they are asking you, so you have to calculate the value of E cell here. E cell will be calculated from the Nernst equation. This will be calculated from the Nernst equation. So from Nernst equation, we will calculate the value of E cell. That is, E cell is equals to E naught cell minus 0.059 divided by N factor log of. Now you have to also write the reaction here. So we know that reaction is nothing. If you see the reaction is Zn2 positive, that is Zn-SO4, and here Cu2 positive to C, right? 2 electrons are getting lost and gained here. So number of electrons will be 2. N factor is 2. Right? Products divided by reactants, that means log of Zn2 positive divided by Cu2 positive. Now if you see this here, this value is already given to you, that is 1.1 for Daniel cell. N factor we have the value 2, right? This is given to be 1.1. This value is given to be 10. We know that log of base 10 is nothing but it is 1 only. So E cell you can easily calculate here, 1.1 minus 0.059 divided by 2. That is going to be the value of E cell here. Then you put the value of E cell here and then you will get the value of delta G, that is minus n Faraday. So now, acha, very important thing is, okay, they have not calculated it like this. Okay, rather what they have done is, they have not done calculation here. They are calculated in RT. So you can't use this formula. Oh, then you have to use the original formula of Nernst equation. What is the original formula? E is equals to E naught cell minus 2.303 divided by RT, right? NRT log of, I think this is the formula that you will use, right? 2.303. Either you can use this also. I think that would be better. That would be better because the question that they have given us addition, subtraction, these kind of question they have given us. So what we will use, we will rather use this kind of value here. That is, we know that delta G is equals to delta G naught plus 2.303 RT log of Q. Log of Q, we know that is Zn2 positive by Cu. Why I am using this formula? Because of the options. Because of the options, I am using this formula, right? Okay. So otherwise, there are different formulas also to answer this, but because of the options, I have to use this formula. Delta G naught plus 2.03 RT. Q is nothing but Q is Zn2 positive by Cu. So that you can easily put here. RT value, 2.03, Delta G is minus NF E naught cell. So you can put the value minus NF E naught cell here, right? When you put this formula here, we know that N factor is 2 Faraday. You don't have to put the value. Options are not like that. E naught value is given to you, that is 1.1. So it is a very, very simple question. If you see delta G, that will come out to be minus 2.2 Faraday. So minus 2.2 Faraday plus 2.303 RT log of 10 is 1 only. So directly that will be your answer. No calculation is required here, right? No calculation is required, but you have to go through only those things where the option will tell you that which formula to use here, right? Okay. Next, this is also a very, very interesting question, right? Because this has two concepts here, surface chemistry, and you have the application of surface chemistry and strong electrolyte, weak electrolyte dissociation. So let us see what exactly they are saying. Molar conductivity of aqueous solution of sodium citrate, which behaves as a strong electrolyte, right? First thing is, it is behaving as a strong electrolyte. Now remember, for strong electrolyte, we know that the graph is like this. The graph is like this. This is under root C. This is infinite dilution. It is like this. It will intercept. There will be an intercept on the y-axis, which is your infinite dilution molar conductivity, right? Okay. So that means this is possible. This thing is possible. This thing is possible. This is already eliminated because it is not increasing. It is decreasing here, right? The slope is like this, right? So that is already eliminated. We know that when you see, when you do the dilution, concentration decreases, and that's why concentration is decreasing, and hence molar conductivity on this side is increasing. So when you do the dilution, okay, molar conductivity will increase, right? Okay. Now out of this, you have to see which of the following is correct, right? So now here, first is, this is the point where you have CMC. What is CMC? CMC is the mycelium formation. So you know what is mycelium formation, right? When you have, let's say this is one compound, and here you have hydrophilic and hydrophobic parts will form the micelle. So basically there is association of molecules here. So whenever you have association of molecules, what exactly happens, everybody? When you have association of molecules, concentration should decrease or increase. So we know that association of molecule means, let's say there are 1,000 of molecules, now they are under one roof. That means their randomness, right, their power of roaming around is exactly decreasing. That means their conductivity is decreasing. So molar conductivity for that one particular mole, the conductivity is decreasing here, right? Okay. So that means the answer, and here it is not decreasing very like this. Okay. Wait a minute. This is already done. This we have, it is decreasing here. It is constant, it is increasing. So increasing is eliminated. It is not constant. It is further decreasing. So answer will be A is the correct answer. Okay. Answer will be A is the correct answer. Is that clear to everybody or not? Right, students? Rohit, don't spam. Okay. So is that correct, students? Everybody? Is that clear? Yes, everyone. Why can't I see your comments? Shocked to see the question or what? Right? So this is the concentration what you will see. Right? Again, I'll explain that. So first thing is, till here we know that strong electrolyte on dilution, we know that concentration decreases and molar conductivity increases. So as your concentration is decreasing, molar conductivity is increasing. But we know that when there is CMC, when there is myceliate formation, in that case, after that, what will happen? Association. And that is why molar conductivity will further decrease here. So that will be the correct answer. So A is going to be the correct answer here. Right? Okay. Next question is everybody, I think, oh, this question, so by mistake, I have taken this. Sure. Now, let us see the next question here. That is, consider the following reversible reaction. Okay. So, there is one reversible reaction here. The activation energy of backward reaction exceeds that of forward reaction by 2RT. The pre-exponential factor of the forward reaction is 4 times that of reverse reaction. Okay. The absolute value of delta G for the reaction is this. Okay. Absolute value they are asking you. Pre-exponential factor means A. Okay. Arrhenius is nothing but they are asking about, talking about Arrhenius factor. Okay. So this is the question that is given to us. Activation energy of backward exceeds of forward. So you can see activation of backward minus activation of forward is going to be how many times? Is 2RT. First thing. Second is pre-exponential of forward divided by pre-exponential factor of forward is 4 times that of backward. Okay, so that is going to be 4. So these two things are given to us. Right? We know that the formula is K is equals to A e raised per minus EA by RT. Right? So they have given you this thing. Right? They have given you this thing and they are asking you delta G. We know that if you are able to calculate the value of this K, you can easily calculate the value of delta G also. Okay, so from that we will answer this. First we will focus on K. Right? So we know that this is given to us in the question. We know that delta G naught is equals to minus of RT natural log of K equilibrium. Right? Okay, this is K equilibrium here. Right? And this is the rate of forward, this is rate of backward. Right? Now, because this is actually a mixture of two chapters, that is equilibrium and chemical kinetics. Okay, that automatically makes it very, very important. Now, if you see K equilibrium, we know that is equals to how you calculate the value of Kc, that is K equilibrium. We calculated K equilibrium is equals to K of forward by K of backward, isn't it? K of forward from the Arrhenius equation, we know. This is from Arrhenius equation. We know that K of forward is A, Arrhenius constant, e raised per minus E of forward by RT. K of backward is AB, e raised per minus EA by RT. Right? You divide these two things. This value you know that is 4. This value is minus EA forward by RT. You take the common here, put it over there. You take the common divided by 1 by RT. You will get EA of backward minus EA of forward divided by RT. Right? Now this value also they have given you that E of backward by forward is 2RT. You put it here, you will get E raised to power 2. So it will be 4 into E raised to power 2 is going to be your K equilibrium. Right? Okay. So once you are able to calculate the value of K equilibrium, you put it there in this formula. That is delta G is equals to minus RT natural log of K equilibrium. Now let us see if that was the option. No. That was not an option based. You have to see the value in integer form. You have to calculate. So we'll convert it into log base 10 only, right? Okay. So let's convert it. So this is 4 into e raised to power 2, right? So RT is the common here. We know that natural log of 4 plus this will be this and this will cancel out each other. Okay. We know that natural log and exponential are opposite of each other. Okay. So they will cancel out each other. This value is going to be 2. Right? Okay. Now, this is a very important part. Right? From here, you can solve it in 2 ways. Okay. I'll just write it here. Delta G naught is equals to minus RT. This is natural log of 4 plus 2. Okay. That will be, you can also write it like this. That is minus RT. Right? This natural log of 4, right? That is nothing but 2 into natural log of 2 plus 2, right? You can take 2 common here, 2 RT, right? Then this will be natural log of 2 plus 1, okay? Now this is minus 2 RT. Natural log of 2 can also be written as 2.303, right? Log of 2 is 0.301 plus 1. Okay, you can solve this value and you will get your answer here, right? Rather than this, you can also solve it like this. This is converted to log base 10. That is why I have multiplied it by 2.303. Log base 10 of 2 is nothing but 0.301. You multiply this, you will get your answer. Put the value of R here, put the value of T here, and you will get your answer. Ma'am, temperature is given to you in the question only. See, RT value is only given to you. Then you have to, don't worry. Array ma'am, natural log of 2 is given to you. RT value is given to you. Then to not at all there is any confusion, right? Then the question is even simpler, right? So because 2 values are already given to you. This is when they have not given you the value of natural log of 2. Because natural log of 2 you don't know. You know log base 10 2 value you know. So that's why you have to convert it into log base 10. But because they have given, here I'll write if they don't give value. If they don't give value, then you have to solve this. Because here they have given you the value that this log, this is 2 raised to power 2, that will be 2 into natural log of 2. Natural log of 2 is given to be 0.7, so there is no confusion in that. RT is given to be 2500, so you put the value of RT, put the value of natural log of 2. Natural log of this will be 2 into log 2, right? So that will be 0.2. You can directly solve the answer here, right? Remember one thing, that here, if they are giving you this in joules, that means the answer always should also be in joules only, right? And here they have also given you in joule per mole, right? Joule per mole they are asking you. So that's why answer, if they write kilojoule per mole, so you have to convert it into kilojoule, right? Okay, understood? Next question is again a graphical based question, right? So again now, if you can see, they are mixing 2 kind of questions, okay? So which of the following plots is correct for given reaction? P naught is the initial concentration of P. So what you can see here, firstly you should know what kind of reaction this is. Is this a first order, second order reaction? That you should know from organic chemistry. If you know that this, we know that this is NaOH, it is going to replace this. So this is a first order reaction, right? We know that this is the first order reaction in SN1 reaction, right? Okay, whenever you have NaOH, this is alkyl halide, it is going to substitute by SN1 reaction. Reason is because here you have 3-degree alkyl. And we know that 3-degree alkyl is if this reaction is happening. See, simple part is SN1 reaction, you have the order 3-degree, then 2-degree, then 1-degree. SN2, you have 1-degree, then 2-degree, then 3-degree. Why? Because SN1 you have carbocation formation and 3-degree carbocation is stable. So if this reaction is happening, then it must happen through SN1 only, right? Okay, only then this carbocation can be stable, only then this reaction is possible. With SN2, this reaction is not possible because 3-degree has no rate for SN2. So this reaction is definitely SN1 reaction, right? Okay, that we are sure about, that this is SN1. So you can take it here SN1. Now jump to chemical kinetics. This is the organic part that you should know. Now you know that this is the SN1 reaction, that means it is first order reaction. Now they are asking you the graph here, right? And you know what's the important part? They are saying which of the following are correct. So you have to see each of the graph. If this was not a multiple answer question, then I would say this is an easy question. Now you have to see everything here. If you see the first part, that the initial concentration and T half, we know that for T half of first order reaction, T half is directly proportional to initial by 1 minus n. First order, it is independent. If you put 0 here, it is independent. If you put 1 here, that will be 0. So it will be independent of the initial concentration, which makes this graph as the correct answer. Okay. That means this is one of the answer that is correct. Okay. Now we have to go through this B, this C and this D. Right. If you see for the first order reaction, initial rate is dependent on the initial concentration or not. Initial rate, it is dependent on the initial concentration, right? Because SN1 mechanism, we know that in SN1 rate is directly proportional to this K, and this is the initial concentration raised per 1. That's how it is a first order reaction. So that means it is dependent on the initial concentration of this P. It is not dependent on the nucleophile. That is how you can say this is the wrong graph, right? Okay, let's talk about if you see Q by P naught, now you have to solve according to time. So here you have to solve the value of Q by P naught. Let's solve the Q by P naught. So what is Q? Q is the final product here, right? So final product will be what? So if you see this graph here, so what is rate? This we know. Achha, we are calculating the value of Q by P naught. P naught we know value. Q is what? The final concentration. That is initial minus final. That is the concentration that you are left with, right? So that is initial minus P, right? We know that P minus P naught divided by P naught will be 1. So here we have 1. Basically it is P naught divided by P naught minus P by P naught. This will be cancelled. That is 1 minus P by P naught that you have. Now P by P naught. How you can answer P by P naught? The simple thing is, we know that here directly, from here also you can solve. Natural log of initial by final concentration is equals to Kt. That is equation of first order reaction. So P by P naught, you can say directly, natural log of P by P naught. See, from here only I will solve. This is natural log of, take the opposite here, P by P naught. That will be minus of Kt. You take the anti-log here, this will be e raised to power minus Kt. That means P by P naught, you can put here e by Kt. So it will be 1 minus exponential minus Kt. Right? So that means Q by P naught is directly 1 by e raised to power minus Kt. That is the graph. Now this graph is the exponential graph, right? And here you can't see any exponential, right? If you see this graph here, Q by P naught, it is exponentially increasing. But if you see this thing here, it is not exponentially increasing, right? Okay. If you see this here, this is Q by Pt. If your time increases, right? This whole part will decrease, that will decrease it. Right, so we can say this cannot be the correct answer because it is exponentially increasing, right? And natural log of Q by Pt, if you see natural log here, if you put natural log here, that is going to be natural log of Q by P naught is equals to natural log of 1 minus e raised to power minus Kt, right? With respect to time, it is definitely not a straight line graph, right? It is dependent on the exponential. So that is why it is definitely not a straight line graph here. So from that we can say only one option is the correct answer here, right? So these kind of questions, if they ask you in one option, then these are easy. But in multiple, you have to solve it for every single option here. Maybe this will be correct, maybe this will be correct. So you have to answer it according to all the options that are available here. Next is, for the following, Electrochemical cell, this is the electrochemical cell that is given to you, right? E cell is equals to 0.092 when this is given to you. Okay. Now, if you see this here, everybody, now if you see this here, for the following electrochemical cell, this is given to you E naught, this when M of 2 positive, M of 4 positive is 10 raised to power X. Now, they are asking you the value of X here. So, one by one, we will solve this. So, this is the equation that is given to you. Nernst equation first you have to find out and then equate it according to this, right? So now here we know that basically what is happening here, H2, right? H2 is getting converted to H positive and here M4 positive is getting converted to M2 positive. That is happening. Now we have to see the full, this is 2H positive. We know that here 2 electrons, oxidation number is decreasing. So 2 electrons are getting gained here, right? Here it is losing 2 electrons, right? Here it is losing 2 electrons. So that is the 2 equations that you get here. From that the full reaction is this when you add both of them. Now when you apply Nernst equation here, then it is E cell is equals to E naught cell. E naught cell will be E naught of cathode minus E naught of anode. E naught of cathode. So cathode is the one which is gaining the electron. So here it is cathode, right? And this is anode. And this is anode. Both reduction potential you need minus 0.059 divided by 2 because number of electron lost and gained are 2, right? Log of product, in the product side you have M2 positive and H positive raised to power 2, right? Divided by M4 positive raised to power 1 and pressure of H2 you will take here, right? Okay. Pressure of H2 is 1 only. Now the concentrations, if you see this value is given to you, right? Okay. Concentration of H positive is given to be 1. So I'll put the value here. This concentration is also 1, right? So that will become, this will become only log of M2 positive divided by M4 positive, right? It will only become log of M2 positive divided by log of M4 positive. Now, if you see this here, log of M2 positive and log of M4 positive is given to be 10 raised to power X. We will put this value here. That is, here you can put it as 10 raised to power X, right? This value is 10 raised to power X, right? Now see this. This will be log of 10 raised to power X, right? So when you solve this, X log 10, it will become X because power will be in the initial stage. So it will be X log 10, that is 1 only. So here this will become X, right? Now, we know that this value is given to us. This value you can easily calculate. Now, reduction potentials here. Let us see if both the reduction potentials are given or not. Here they have oxidation, the oxidation number is decreasing. So, reduction potential is given to you. What about the other reduction potential? Reduction potential of H2. See, reduction potential of standard hydrogen electrode is 0 only. So, that will be nothing but 0.15. E naught cell will be 0.151 minus 0, that is 0.151. Right? Because the reduction potential of cathode minus anode it is, so it will be 0.151 only. Right? This value we have put it here, n factor is 2. This we know that it is 10 raised to power x. Not till here you have solved it, this will cancel out and this will minus will also cancel out. Now what you will get, log of M2 positive, log of M4 positive is 2. Now you know how you can solve this easily. If you see this here, this will be log of M2 positive by M4 positive is 10 raised to power x is equals to 2. Right? This will be x is equals to 2 directly. Why? Because we know that this value is x log of 10 equals to 2. Log of 10 is nothing, that is 1. So answer will be x is equals to 2 here. Right? So directly you can put the value, that is x is equals to 2 is the correct answer. Okay. Next question on your screen we have regarding the match the following, right? But remember that in these kind of questions, it's not only one match. PR, D is PR, D is PRT, right? E is QS, A is PQ, right? So there are different, that means one option can have 2, 3 values also, right? So we'll talk about the first case here, right? First case they are saying is, they have given you some values here, some cells here, and they are asking you which is spontaneous, which is non-spontaneous. For this, you should know the reactivity series. For this, you should know the reactivity series. For example, let us see the reduction tendency of Au4 positive is more than the tendency of Li positive. Okay, so you have Li here, you have Au here. We know that here what you have, this is 0 and this is x minus 4 is equals to minus 1, that is plus 3, right? So if you see this here, they are saying that the reduction tendency of Au4 positive is more than reduction tendency of this. That means we know that this is AC, this is also AC, this is also AC, this is also AC. So whenever you are calculating the E0 value is nothing but cathode minus anode, right? So that means if this tendency, this reduction potential is greater, then the E0 value, if this tendency is greater, then E0 cell should be, E0 value will be less than 0, that is negative, right? Negative means it is going to be negative only, na, because this they are saying is more as compared to lithium, right? So that is going to be negative, yes. So that is going to be negative. We know that delta G is equals to minus NF E0 cell, right? So if this is negative, delta G will be positive. Delta G will be positive means it is a non-spontaneous process. So A is Q. A is Q. This is not possible. This is possible. A is P and Q. Okay, A is Q. Right? Now let us see if any of the other thing is possible. If it is non-spontaneous, it is not spontaneous. That means A is not P. This is not possible. Right? Then we have to see whether between C and B, which of the following is correct. Is S true for it or not? E0 is less than 0. That is true. So it is also S. That means both the things. Now you can't eliminate. The biggest mistake that students do is they eliminate this option here. You can't eliminate. Yes, they have missed here S, but what if any of the other statement is correct? We have to see the incorrect. We don't have to see the missing thing here, right? So chances are this will be correct, but this also can be correct, okay? So next is Zn. Between Zn and this, the tendency of Zn to positive is more than An. This you should know from the reactivity. So Zn has more tendency. Again, this is more. That means again for B also it is non-spontaneous. B is also Q. B is also Q. B is also S. That means here also E0 is S. Okay, here it is missing. Right? Okay. Again, this is not incorrect, but this is not exactly the correct answer. This is more valuable to us. Let us see the third part here, where you are doing the purification only. So with purification, we can leave it, right? Okay, electrolysis basically you are doing here, right? Let's talk about the D part here, right? With purification also, so you can see that purification also, Cu to Cu2 positive is less as compared to Cu2 positive to Cu. So that is why it will be a non-spontaneous process only. Electrolysis process is a non-spontaneous process. So C is Q over here also. Now D will tell you whether which of the following is correct, right? See, T is here also, T is here also. Now if D to P is correct and D to R is also correct, then the answer will be B is the correct answer. Okay, so now let us see. If you talk about nickel here, now the tendency of Cu2 positive is more than nickel, right? So Cu2 positive is more, that means cathode minus anode. This will be E0 is positive. That means this is R is correct, okay. Dr is correct, right? Then this is a spontaneous process. D of P is also correct. It is a galvanic cell, that is also correct, right? Because it is spontaneous. So that means B will turn out to be the correct answer here, right? This is not wrong. There is no option that is wrong, but this is giving us more information. So answer will be B is the correct answer, okay? Okay, students, got it? No reply, right? I should stop taking the classes of JEE Advanced or what? You tell me, I'll stop taking the classes then. If you think that these are not beneficial for you, you don't have to chat in between, then I think I should stop only, right? Okay, that will be more beneficial. That will be more time saving for me as well, right? Okay. For the system, now the next question is, this system is given to you which was treated with only A. The equilibrium concentration of A equilibrium is correctly related to B equilibrium and C equilibrium. How? Here, very interesting, easy also. If you see this, let's try to answer the value of minus the disappearance of A in terms of B and C. Disappearance of A divided by disappearance will be minus dA by dt. In terms of this, it will be K1 into A minus of K minus 1 into B. So K1 into A minus of, because backward we are doing, K minus 1 into B. Regarding this, it will be K2 into A because it is forward. For backward, it is minus of K21 into C. K2 into A and minus of K21 into C, right? So now we know that at equilibrium, they are saying, at equilibrium, the change in concentration is going to be 0, right? So dA by dt, that is going to be, that means it's not like the rate will change, it will disappear. At equilibrium, we know that it will be decreasing or increasing, but it is at the same time. So there is no observable change that we can see here. So that is why dA by dt is equals to 0 here. So you put all this equation equals to 0, right? Now they are asking you the value of A equilibrium in terms of B and C. So do the mathematics, take A equilibrium common from this and this here. You will take it to this side, that is, it will be plus of K B equilibrium, plus of K minus 2 C equilibrium. Then take common K1, K2, you will solve the value of A equilibrium here, right? So basically, this is chemistry. After this, you have mathematics, right? What you have to do, you just have to solve the value of A equilibrium in terms of B and C, right? By taking common, and that's it, right? Okay. Next question, let us do that. The conductometric titrations. Now they are saying that the conductometric, now this is a very, very interesting question. Okay, this is one of the most important questions that has been asked in JEE Advanced, right? Okay. Now the question is, in a conductometric titration, small volume of titrant of higher concentration is added stepwise to a larger volume of titrate. Now you know what is titrant and titrate. So when you talk about a conical flask, okay, here you have titrate and this burette has titrant, okay. Now they are saying that higher concentration is of titrant and lower concentration is of titrate, okay, is added stepwise to large volume of titrate of much lower concentration. This is having lower concentration, that is having higher concentration. And the conductance is measured after each addition, right? So the limiting conductivity values for different ions in the solution are given below. For different combination of titrates and titrants given in list 1, graph of conductance, match entry list 1 with appropriate with entry list 2, choose the correct option here. Now this question you have to know 2, 3, like it's a very, very important question, okay. So if you see this here, list is given to us, corresponding graph is given to us. Now first is titrate and this is titrant. Titrate is KCl. If you see for this is K positive and Cl negative. That will 7.4 plus 7.6. 7 to 14, that will correspond to be total limiting molar conductivity will be 15. So I'll just write the total limiting molar conductivity, that is 15. For EgNO3, it is going to be, where is Ag? Ag is this. NO3 negative is this. So it is 6.27 to 7 plus 2. Right? What is that? 6, 6, 12, 13, 13.4. Okay. So that is going to be 13.4. Now, if you see this here, right? In this case, the titrate which is higher in concentration and this is lower in concentration, that has higher molar conductivity as compared to this. Now we know that what exactly is happening here. What is exactly is happening here? What you have to remember. First, you should remember one thing, that in these graph 1, 2, 3, it is decreasing, then it is increasing. Here it is decreasing, then it is constant. Here it is increasing, then it is constant. First, we will see whether it will decrease or it will increase, right? Because the higher concentration titrant, wait a minute, titrant you have, na? No, this will be the higher concentration. No, yes. This will have the higher concentration. This will have the lower concentration. That is given in the question, okay? So that is having the higher concentration, but the molar conductivity is less here. And here you can see AgNO3 is getting converted to KCl, right? Is that titrant is no. KCl is getting converted to AgNO3. That means you are getting converted, you have more molar conductivity is getting converted to less molar conductivity. That means the conductivity is going to decrease here. It will not decrease like this and then increase, it will decrease only, right? Here you can see the decrease is very less, here the decrease is very. So this is not possible for A. There will not be increment because you are converting more molar conductivity to less molar conductivity. That means the conductivity is decreasing, right? So in that case, this cannot be the answer. This can be the answer. This can be the answer. This also, this cannot be the answer. Here it is decreasing. This can be the answer, right? But here remember one thing, the difference is very small, right? The difference is only 2 point something. So that is why it will not decrease to this much extent. It will slightly decrease here, right? Okay, it will slightly decrease here. That is why the answer is decreasing only now. Yes, it is decreasing, right? So it will slightly decrease here, not to that much extent. Now, after this, because after this, what will happen? The conductivity will increase once all of this is consumed, right? That means more molecules you will have, the definitely it will going to increase only. So answer is with the P you have 3, right? With P you have 3, right? That is the correct answer, right? That means C is the correct answer, but we will see for Q, R and S as well, right? Right. Right. Now here what you have, this is AgNO3, that is 13.4, KCl is 50. Now here simple thing is, you are getting converted from a titrant to this, right? Okay, titrate is getting converted to this. So it means you are going from low molar conductivity to high molar conductivity, right? That means what will happen? The conductivity will increase or decrease here. That will surely increase here. And we have only in this case conductivity is increasing. In this case conductivity is increasing, but to firstly decreasing, then increasing. First it decreases, then increases. That is not a point of strong electrolytes, right? So that is why it will be 4th is the correct answer. So that is why Q is 4, right? That is why Q is 4. This is 3, right? Then you have R. R is what we have here. Strong acids and strong base here. Strong acid and strong base are totally going to neutralize each other, right? Okay. They are totally going to neutralize each other. Okay, students? Now, if we are saying it is totally going to neutralize each other, firstly, what you have? First, you were adding HCl. What is getting formed? You have the formation of NaOH, right? Okay, so that is why, firstly, your NaCl is getting formed. That is why the conductivity will decrease, right? Very highly it will decrease, right? Okay. Why? Because you have Na, let's say this is 5, OH is what, 19. So this is 19, 20, 22, 20, 24.1, right? 24.1. What is HCl? HCl is 35, Cl is 7, so 35 plus 7, 40, 42.6 I think, right? So can you see this is almost a double, okay? This is almost a double. So when you decrease it, there will be a great decrease here. It will not be a small decrease. This is a very high decrease. This is also a very high decrement, right? But here after this, it is constant. But it can't be constant after this. Can you tell me why? It can't be constant after this because the HCl that you are adding here, right? That is also a strong electrolyte. So that will also dissociate here, right? That is the reason after this also there will be conductivity will be more only, right? So answer will be 2 is the correct answer. Last one is NaOH and CH3OH. Now let us see this thing. This is the titrant that you are adding, right? Now let us see the difference. NaOH is what? NaOH is 24.1, right? And CH3COH is given to you what? CH3, that is 4.1. H is given to be 35. 35 plus 4, that is 39, right? 39.1, right? So definitely there is not that much. Yeah, there is a big increase around of 10 units, 10 more than 10 units you have, 15 unit decrease you have. That means definitely it is going to increase to a large extent. Is there any other condition where it is increasing? Here so it is increasing, so it is not possible only. Here it was small increase, right? But after this it is constant. Can you tell me the reason? Because the titrant that you are adding is weak electrolyte. The titrant that you are adding is weak electrolyte. Weak electrolyte will not dissociate to that much high extent, okay? So that here you are adding HCl. That is why after the neutralization also, HCl is getting dissociated, and that is why there is increment in the molar conductivity. The conductance is more, the ions are more. But in this case, the dissociation, once the neutralization is done, even after adding CH3COH, which is not getting dissociated, so the molar conductivity is not increasing. That is why we say it is constant. So answer will be S. This 5 is the correct answer. Okay, right? Yes, beta, I will definitely take that. Don't worry, right? Okay. Next is okay. Next question is, find the equilibrium constant for the reaction. This reaction is given to you, right? Given E naught value, these three things are given to you. Let us see that how to solve it, right? Okay. Yes, everybody, let us see that. Find the equilibrium constant they are giving you. See, simple thing is, for equilibrium constant, firstly we know that E naught is given to you. You can calculate the value of delta G. From there, you can calculate the value of equilibrium constant. So firstly, we will calculate the value of delta G. For delta G, you should know what you should know. Delta G of E naught is given to you, right? Delta G of overall reaction you should know, right? So overall E naught you should know. Here it is ln 2 positive to 4 positive, right? Here it is ln, I will just write it here. This is 2 positive to 3 positive we need. Here this is ln 2 positive to ln 4 positive, right? Here it is 3 positive to 4 positive. We need 2 positive to 3 positive, right? So that's why we have to apply the conservation of energy here, right? That is delta G is additive in nature, right? So what we will do, we know that in ln of 2 positive to ln of positive, that is given to you ln of, acha, this is ln of 2 positive to positive because that was not visible to me as well. This is given to be ln of 2 positive to ln of positive, right? Okay. Here I think that is given to be 3 positive to positive. Okay. Acha. This is given to be ln of, this is ln of 3 positive to ln of positive. Right? Now if you see this here, conservation we will apply here. What we know, ln of 2 positive to positive is given to us, E naught value is this. ln of 3 positive to positive is E naught value is this. Is this the reduction potential? Yes, it is decreasing. It is decreasing. Both are the reduction potentials, right? We know that delta G is equals to minus E naught minus NF E naught cell, right? So N value is 1, N value is 2, right? So what you will do here, right? So directly we'll put the value here. This will be 8, 0, not this, because when you multiply it by 2, that will be delta G. I'll put the minus NF E naught cell, right? So delta G naught will be minus N factor here is 1, N factor here is 2. Faraday we have taken as it is, right? This E naught value is multiplied by 2, right? Okay, both the values are given to be 0.4. So this is given to be 0.42. So I'll write it as, this is given to be 0.42. So this will be 84 only, right? We got the delta G values of both of them. Now, if you calculate the ln of 3 positive to ln of 2 positive. So basically, beta, what you have to do here, I'll just tell you that. This is ln of direct method is ln of 2 positive to ln of positive. You can also write it as ln of positive to ln of 2 positive to ln of 3 positive, and this is ln of 2 positive to 3 positive, right? Ln of positive to ln of 3 positive, right? Ln of positive to 3 positive, NF factor is 2, and here E naught value is given to you, that is 0.42, right? Ln of positive to 2 positive, we have to calculate value. Electron is 1 electron you are gaining. E value you have to calculate. Ln of this 1 N factor you have, and E value is given to be 0.4, right? Minus of 0.4. So this is already given to you in the question, right? Now what you have to see, this is minus, this is minus. So we know that this 1 of E plus, you add these two things, 1 into E plus minus of 0.4, right? Okay, equals to minus of 8.84, right? From here you can get the value of ES minus of 0.84 plus of 0.40, and then you will get the value as minus of 0.4, right? So directly also you can get this value. Rather than doing this, I would ask you to do this, right? So this plus this is equals to this. This is framed by this question only, right? This is framed by this part only. So I'll just write the common thing that you can use here. I'll just write it here only, right? That you can use, okay? In all the conservations. In all the conservations you can use, right? Because based on this, questions are very important. And questions are very easy also based on this. So if you see, this is A to A positive, let's say positive, A to 2 positive. This is, here N factor is, let's say N factor is N1, this is N2, this is N3. This is E1, this is E2, this is E3. So remember that N1 plus E1 plus N2 plus multiplied by E2 is equals to N3 multiplied by E3. That you should remember, okay? That you should remember, right? Always. That this thing is N1 into E1 plus N2 into E2 equals to N3 into E3, right? Directly you can put it here and solve that. So once you have that, now for this reaction they are talking about, this reaction. Here if you see that this one, Cu2 positive is getting converted to Cu positive. Ln2 positive is getting converted to Ln3 positive. Here oxidation number is decreasing. So that means the reduction is happening here. Right? Here oxidation number is increasing. That means oxidation. You always have cathode minus anode. That means here it is going to be Cu2 positive reduction potential minus anode. Right? So E naught is going to be the reduction potential of Cu2 positive by Cu. That is cathode minus anode. Cathode minus anode, right? Cathode is given to you. So here you have to calculate the reduction potential, that is E naught of cathode reduction potential minus E naught of anode reduction potential, right? That is your E naught cell. Now if you see this here, this is reduction potential. And if you see this thing here, what you have calculated for ln of this. That means you have calculated the oxidation potential. So reduction potential will be opposite of this or not, right? Because you have calculated it, wait a minute, you have calculated it for, this is for, wait a minute, this is for ln2 positive, this is ln2 positive to ln is given to you. Opposite is only given to you. Ln2 positive to Ln was given to you. Ln3 positive to Ln was given to you. So you have calculated the opposite only. That means you have calculated the reduction potential only here. Right? So you have to see the arrows as well. Because here it was given to you Ln2 positive to Ln positive, Ln3 positive to Ln positive. That means this thing and this thing was given to you. right? So you have calculated this thing only, right? You have calculated for reduction potential only. So reduction potential you have calculated, put this value, you will get the answer for E naught cell. Then we know that E naught cell and equilibrium constant is E naught is equals to 0.059 log of K. Then that will be log of K is E naught by this. You put the value here, the value is 0.59. Put this, you will get 10. Log of K is 10. Log of K is equals to 10. That means K is equals to, oh, chalo, koi baat nahi. I'll just erase this because I can't write it again, right? I think you have understood what I was telling you, right? So you can put this value, K is equals to 10 raised to power 10, directly you will have it, right? Okay. Next question is, we have taken a saturated solution, right? We have taken a saturated solution here where AgBr KSP is this. Okay, two things they have actually mixed here is solubility product, and you have the ionic conductivities here. Two things, right? So we have taken a saturated solution of AgBr. AgBr, we have taken KSP value is this, right? If 0.7 molar of AgNO3 was added to 1 liter of this solution, right? This is what they are saying. Find the conductivity of this solution in terms of 10 raised to minus. Now students, they are asking you to find the conductivity in S per meter, right? That means conductivity is nothing but it is kappa by molarity into 1000. If they are asking you to calculate this in per meter, right? So they are asking you find the conductivity. If this conductivity is in Simon per centimeter, so answer will be this formula you will use. You will not use this formula. This formula you will not use. This formula is used when you have centimeter here. When you have meter, you put 1000 in the denominator, okay? So here kappa value is what? Kappa is conductivity. So that will be molar conductivity multiplied by molarity into 1000, right? Now you have the infinite molar conductivity for each of the ions here, right? This is for Ag positive you have. This is for, I think, Hg positive, we have taken a solution of Br. This is Br negative, right? And this is NO3 negative, right? So we have molar conductivity of all of these, right? So now what we will use, we will have to find the concentrations here, right? Molar conductivities we have, right? So what we will do here, right? So the solubility of AgBr in 0.10 raised to minus 7 AgNO3 solution is determined as what? Now here you have the common ion effect. Two things you have, AgBr and AgNO3. Now first thing what you should know is initially what will happen, they have given you two things here. That is, we have taken a saturated solution of AgBr, KSP is this, if point this of AgNO3. That means AgNO3 has the concentration 10 raised to minus 7. So this is 10 raised to minus 7. So this will be 10 raised to minus 7 after achieving equilibrium. So this will be 10 raised to minus 7. Right? Here you will have solubility initially will be 0. After achieving the equilibrium, after achieving the saturated point, it will be S and it will be S. Right? So here what you will see, because Ag is here also, you have to add 10 raised to minus 7 here. You have to add solubility. That is how, this is the thing that you got here. This was solubility plus 10 raised to minus 7. This was 10 raised to minus 7. Now, KSP value, you know, KSP value is given to you. We know that KSP in this format we have to use. That is Ag raised to power this and Br raised to power this, right? Eg is nothing but that is solubility plus 10 raised to power minus 7 and this is S. Now you can ignore solubility in terms of when you have 10 raised to power minus 7, you can directly write it as 10 raised to power minus 7 into solubility. KSP value is given to be 14 into 10 raised to power minus 14. You can directly solve the value of solubility here, right? Directly you can solve the value of solubility here, right? So once you solve the solubility, that is coming out to be 3 into 10 raised to power minus 7. You put it here, right? You will get the concentration of Ag, Br, right, and NO3, all of them you will get here, right? Now what you have to use, the concentration of all of them you have calculated, limiting molar conductivity is given to you, multiply all of them and calculate the value of conductivity, that is conductivity of each of them is conductivity of Br plus Ag plus NO3 negative. That is what I told you, kappa is equals to molar conductivity into molarity into 1000. 1000 will be common, that's why together we have multiplied it by 1000, right? This is the molar conductivity and this is the concentration. So if you see Br concentration is this, molar conductivity is 8 into 10 raised to power minus 3, that is given to you in the question, that is 8 into 10 raised to power minus 3, right? Similarly, molar conductivity of Ag, that is given to be 6, I think, yes, 6 into 10 raised to power minus 3, right? And the concentration you have calculated. Similarly, for NO3 concentration, you have calculated 10 raised to power minus 7, and conductivity is given here, right? Conductivity is given here, right? Important part was this thing. Usually, student use kappa into 1000 by molarity. That is not the formula when they have asked you, especially in per meter. Okay, that is the important part here. This is where you can do the mistakes. Otherwise, rest is calculation part. You can easily solve it. Okay, right? Now, next is next question is, standard electrode potential data are useful. So this is the data that is given to you, are useful for understanding the suitability of an oxidant in the redox reaction titration. Some half cell reactions and their standard potentials are given to us. Now what you will see here, very important thing is, standard electropotential of this, identify the incorrect statement regarding quantitative estimation of aqueous FeNO3 twice. Okay. So, Fe means FeNO3, estimation of this, standard electron useful for understanding suitability of oxidant in the redox reaction. These are the two oxidants that you have. Okay. Firstly, see the oxidants. These are the two oxidants you have, right? Some half cell reaction. Okay, we want to oxidize. See, here it is Fe2 positive. That means here it is Fe3 positive. That means you have to convert Fe3 positive to Fe2 positive. That means you have to, basically what you have to do, Fe3 positive to Fe2 positive, right? Quantitative estimation of this. So to oxidize this thing here, right, you need to have one oxidant here, right? So oxidant can be KMNO4 and K2Cr2O7, right? And in that solution, you also have acid, that is Cl negative, right? Now they are asking you which can oxidize this iron, which cannot oxidize this iron, which of the following statement is incorrect here? Incorrect statement they are asking you. See students, first thing is, if you talk about you have to calculate the E0 cell here. Firstly, let us oxidize, let us use this KMNO4 against this Cl, right? Because in this solution, if you also have HCl, acid also is present in the solution, then this oxidant should not react with the Cl. Only then it can react with this Fe, right? So that means E0 cell is equals to E0 of this and this, right? Right? Now, here if you want to see E0 of cathode, you want minus E0 of anode, right? So what is the E0 of cathode here? Cathode means reduction. Reduction means the oxidation number should decrease here, right? So if you see the oxidation number is decreasing here, here it is MnO4 negative, here it is gaining, this is the reduction. If it is reduction, that means it is undergoing cathode, so it is 1.51 minus of anode. Anode should undergo oxidation here, right? So here what will happen? Reduction potential of this anode you need, reduction potential is given to be 1.4, right? So this is your anode. See, oxidant will always be on the cathode side. Why? Because oxidant is oxidizing something, it is itself getting reduced, so it will be on the cathode side. So that is why both are on the cathode side, right? We have to see on anode side what you can have. So this value is going to be positive. That means this process is possible, right? That means uh, MnO2 can be used in aqueous HCl. That is not possible. Why? Because if you have MnO4 negative, it has two choices, Fe or Cl. So rather than choosing Fe, it will choose Cl here, right? Because the reason is when you put E naught cell is 1.51, that is of Mn, and for this reduction potential is minus 1.71, that is coming out to be negative. So if E naught cell is negative, if E cell is negative, then delta G is positive. That means it is a non-spontaneous reaction. That means it will not be able to oxidize this iron here. We need oxidation of iron. They are saying with quantitative estimation of FeNO3 twice. That means we need iron here, not Cl here. We don't want to estimate that. So this part is not possible because otherwise it will choose Cl here, because in that case it is a spontaneous reaction. In this case it is a non-spontaneous reaction. So answer will be this statement is not possible, right? If you choose any of them, Cr2, see, if you have MnO4 can be used in aqueous H2SO4. Aqueous H2SO4 is not given to us in the question. We have nothing regarding H2SO4, so we can't comment on this. Right, so that is why this may be possible only. So we can't say this is incorrect because that is not given to us in the question, right? But this we can say that Cr2O27 can be used in aqueous HCl. Why? Because if you see in this case Cr2O7 is 1.38. So E naught cell will be 1.38 minus, if you use Cl here it will be minus of 1.4, that is negative. That means delta G is positive. That means it will not react with, it is a non-spontaneous reaction. It will not try to react with the HCl, rather it will choose this only because that is also non-spontaneous, right? Okay, if this is with Cl, it is non-spontaneous, then it will not choose Cl here, right? So that is possible here. So answer is A is the incorrect option here. Got it, everybody? Next question is, I think this is the last second question. Standard solution of KNO3 is used in making salt bridge because. Now salt bridge they are asking you to make, right? Saturated, it's a saturated solution of KNO3. This is a very, very simple question for JEE Advanced. Why? Velocity of K is greater, velocity of this is greater, velocity of both are nearly the same, and KNO3 is highly soluble. So answer is C. That is the mobilities, the velocities of the ions should be same, only then they can act as electrolyte of the salt bridge, right? Last question, right, of today's class, that is the correct order of equivalent conductance at infinite dilution of LiCl, NaCl and KCl. Simple thing, remember, infinite dilution is directly proportional to the, inversely proportional to, or you can say yes. It is directly proportional to size of, I'll talk about hydrated ion. Size of hydrated ion, which is directly proportional to the size of ion. So what do you mean by that? See, if you talk about this thing here, if let's say this is the size of lithium, this is the size of, let's say, potassium, right? Now, in this case, size is less, so more molecule can be attracted here, right, of water. Here the size is bigger, so less molecules of water will be attracted here. So this will, water molecules will get attracted here, that will make this as the bigger hydrated ion. Okay, so that is why I have written here that always remember, you can remember it from hydrated ion. If hydrated ion size is large, their molar conductivity is going to be less, right? Because conductivity, see, when we talk about conductivity, we are adding, so simple thing is that you have this solution. You are diluting it. That's how you are calculating the molar conductivity here, right? So in this hydrated solution, we don't have simple ions. We have hydrated ions. So if hydrated ion is very heavy, see if someone gives you a big bag on your head, right, you won't be able to walk very properly. If you're not having something in your hands, you can easily walk, right? So with lithium, if it gives you so many hydrated ions, it's very difficult to walk. So that is why it has less conductivity. So either you can remember this relation directly or you can understand the concept behind it. Remember that molar conductivity is directly proportional to the size of the ion. If size of the ion is less, then molar conductivity is also less. So answer is B is the correct answer here. Okay, concept I told you why it is so, because of the conductivity. The walking tendency of the ion also decreases, right? Smaller ion will catch more hydrated ions, and that is why it will be heavy. As a hydrated ion, it will be heavy, and hence its conductivity will automatically decrease. Okay, so that was all about JEE Advanced questions. But what I saw that okay, so what I observed that you guys don't interact, you guys don't share, you have no interest, right? So that is very, very disappointing on your part. So if that is so, do let me know. I'll stop taking classes on JEE Advanced only, right? Because my energy also gets wasted in taking out questions, right? Then doing standing here, solving the questions for you. If you guys are not interested, you can let me know about it, right? That ma'am, we are not interested. At least the students who are present here, those I feel should be interested here. If you are not interested, then do let me know. Why to waste your energy and my energy, right? Okay, let's not do that, right? So that's it. And for all the students who are here for JEE Advanced, then students here you can see in the live section here. Wait a minute. In the live section here, uh, in the description box, you will see rank accelerator JEE Advanced questions. Okay, this I am going to take up these questions on Thursday, right? Top questions of JEE rank accelerator book. And if you want to purchase this book, which is a must for JEE Advanced, because really interesting questions are given in this book, right? So physics, chemistry and mathematics is provided to you at 1665 only. Yes, 3 books are provided to you at this low cost, and here with solution everything. And if you're someone who wants some mentor to guide them towards it, then we have Eklavya batch for you, where this Eklavya questions, where these rank accelerator questions, the previous year questions of JEE Advanced are discussed in detail. Every single question of previous year question of JEE Advanced is being discussed, and there are also doubt sessions that are going currently in this batch. So you can go and pick this batch here. And that's it for today, students. That's it. So I'll see you in the next class. Okay. Bye-bye. Take care. See you all. This is Diksha Kaushal signing off. Bye-bye.